So hello everyone, this is the trains video which I believe is the continuation part of train time speed distance which I've explained in the last videos. And in the train similar concepts will be used, like for example when we say train there will be the distance, there will be speed, time. So distance is equals to speed into time would be our basic formula that we are going to use. So that is distance is equals to speed into time. And the concepts like relative speeds, definitely we will be covering the questions of the concepts on the concepts of relative speeds, right? Why? Because these are the most important type of questions that we can say, and initial 2-3 questions, 3 to 4 questions are on these still objects, and then again we will go for the relative speed questions. When I say still object, for example, if this is the most basic question, right? So here a train of 100 meters is running at speed of 30 km. You have to just simply find the time taken by it to pass a man standing near the railway line. Here man is standing near the railway line, which means man is just still, right? Man is not moving. Simply here, as man doesn't have any kind of length or anything that we can consider as something that will be used for measuring the distance, is not there in the case of man. But when we say bridges or platform, we have to consider the length of bridges and platform. Now if this is kind of if this is sounding kind of gibberish to you, I'm going to make sure that definitely you will get each and everything that I'm saying right now if you just go with me in this whole video. As in the first video, this is the most basic question I can say, where a man is there and man doesn't have a length. If I just explain this to you, this is a man, for example, this is a man, he's standing at the railway line. He's standing at the railway line. If a train has to pass through this man, through this man, and we have to calculate the time that is required for the whole train to pass through this man, what would it be in this general scenario? It would be simply the length of the train. Am I right? This only would be the length of this is the length of our train. This is our entire train itself, and this is going to pass through this man. So this is our end point and this is our starting point after passing through this man. This is nothing but length of the train. Am I right? So in this scenario we will simply going to use length of the train. Now for example, if it is not a length, it is not a man, if it is a platform. If it is this is a platform, okay? And this is our train. So this is our entire platform. This is our train. Now if I say what is the time that is required for the train to pass this platform, what would it be? First of all, it has to go through its original length. Am I right? So it starts from here. It has passed the platform. It is on the platform, right? It is on the platform. So we have to consider the length of the platform itself. And now it has started moving and it has come here. Now it has passed the platform. We have to consider the length of the train itself. Am I making myself clear here? But because this is the most important thing, I believe. I think in the upcoming questions, this will be necessary. And definitely I'm going to explain there also. So just don't just get afraid right now. First of all, just try to understand this scenario here if you can. So when train is moving from here, it has crossed the platform. It has similarly, when it has reached here, now this is the starting point for the train and it has reached here. Now here it has crossed the platform. So the entire time span that was there, the train was covering the distance from train as well as the platform, length of the train as well as the length of the platform. So when we consider something that has a certain length, this is the platform. Similarly, it could be a bridge, right? Now instead of a man, if it was a pole, it would have a similar scenario. Why? Because pole also doesn't have any kind of length. It definitely, the length of the pole is negligible, not the height, just simply width here. Because it is passing to the pole means what? We are just simply considering the width here, right? So this is in the first question. Simply a man is standing there and train is passing that man. So here a speed is given, speed of the train is given as 30 km per hour. And don't be afraid, I'm going to explain its concept in the next questions too. So speed of the train is given as 30 km per hour and train length of the train is given as 100 meter. So distance is equals to speed into time, as we know it already. Distance is equal to speed into time. Distance is nothing but the length of the train here, as we do not have to consider length of the man. And speed would be what? 30 km per hour. And make sure when you're dealing with this kind of questions here, as units are always changed, you're different, as it is in the meter and it is in kilometer per hour. 30 into 1000 upon 60 into 60. Here we have converted this into meters per second. And this is time. Why? Because when we say it is crossing the man, or man is crossing the train, something like that, man is not crossing here, and when we say man is crossing there, the concept of relative speed will be used. And that is the next type of questions, and we will definitely going to cover the relative speed questions. Just stay tuned with me. Okay, so when I say a train is crossing the man, the time span that is needed is just in seconds, right? It would not need hours to cross a train, cross a man, right? It would just need seconds. Therefore, we will convert this entire scenario, entire thing into seconds, into meter per second. So if we solve this, that is 3 2s are, so this is 12. So this is nothing but 12 seconds. I hope you understand that. Why? Because time would be in seconds, and 12 seconds are required for the train to pass the man. Second question. Here we've as in the previous question, we have seen the object which doesn't have any kind of length in itself, right? Similarly, it's not only about the man. If we, for example, the object like pole, right? Pole also doesn't have its own length, right? Its length is something that we can directly neglect it, right? But the opposite of that, here we have a railway platform. Now, railway platform that is 165 meters, it is not negligible, right? Its length is not at all negligible. We have to consider it when we say like train is passing through the platform. We have to consider the length of the platform also, because what kind of questions that usually ask, what here, as in this question, how long will it takes to cross a railway platform which is 165 meters long? So how much time will be required for the train, right? As if in the previous question I've discussed this particular concept, right? Like this is the length of the platform, this is our 165 meters long platform, right? And this is the train which is coming. So this is the train which is coming. This is the length of the train, which is in this case, it is given as 110 meters, right? So now this particular length of this particular train is passing through this platform which is 165 meters. What would the time that is required? First of all, the time which is required for this to cross itself, I mean to cross this particular point, and then again to cross this whole distance. Am I correct? So cross this point, because this here it is the starting point of the train. For example, here it is in the steady position itself, and then it has to cross the platform. First of all, it needs to cross its self distance, its own distance, which is this 110 meters, and then now after getting till here, it is already here, right? It has passed this distance, which is the length of the train. Now, to pass this platform, we need to consider the length of the platform. Now, it would pass this platform and come here. So, this whole distance is the time that is required, that we need to find out, right? Because like this is the length of the platform, 165 meters, and we have to consider, and that is specifically asked. That is only the specifically it has been asked, like what will be the time that is required for the train to cross a railway platform. So we need to cross the whole platform. So from here it will be the end point of the train, and this will be the starting point of the train when it would have been already crossed the whole platform, right? Length of the train plus length of the platform. I hope it is understood, because this is important, right? Because this is the most important type that we need to understand, because this is the important questions that are repeatedly asked in the multiple examinations. And then again, it's not only about the platform. There are this different questions like where concept of bridges is also used. It's a completely similar concept, right? Where we have to just simply add the bridges. So as we know that distance is equals to speed into time, and distance here means LT plus LP, length of the train plus length of the platform, which is equals to, now here the speed of the train, only the speed of the train would be required because it is only in the moving state, and then time of the train that is required for the passing of the whole platform, that is there, right? Now what is the length of the train and the length of the platform? It is 110 plus 165 meters, and then speed of the train is nothing but 132 kilometer per hour. It is 132 kilometer per hour, and this is in meter. This is the meter. Let me just make sure that you know that the units are completely different, and most of the times, in most of the cases, the units will be different. Speeds would be in kilometer per hour, and the units and the train and the distance would be in meters, and then time. And when we talk about the time, it will be seconds. Why? Because definitely when we talk about crossing of the platform or crossing of the pole or the man, it will be in seconds. So time would be in seconds. So first of all, we need to convert this 132 kilometer per hour into 132 into 1000 meters, right? And by hour it is. By hour means what? 60. That means 16 minutes. Now again 60. Now this is seconds. Now this is, we have converted this kilometer per hour into meter per second into time, and this is nothing but 110 plus 165, that is 275. So this is 275. Now when we solve this whole equation, here we will get our t as, right, simply 15 by 2 seconds. Right? You can solve this and try to get the answer. You will get the 15 by 2 as a second, and this is the time that will be required for the train to cross the railway platform, which is 165 meters long. So this is our question. Here we have a man who is standing on the railway bridge, which is 180 meters long, and then he finds the bridge in 20 seconds, and crosses himself in seconds. Now we have to find the length of the train and its speed. It's a similar concepts here. We will use the similar concepts that we have used in the previous questions, right? Now, in this case, a bridge is used, right? Here, bridge also has certain amount of length that we need to consider, right? So, as first of all, a man is standing on the railway bridge. Bridge length of the bridge is 180 meters, and then he finds out that train crosses the bridge in 20 seconds. Time taken by a train to cross the bridge, right? Time taken by the train, just let me make sure that you know that this is different scenarios altogether. When the train is crossing the bridge, and when the train is crossing, himself means whom? That particular person. So here, and then in that case, we do not need to consider any different lengths, but here we need to add the length of the bridge. So first of all, the time taken by the train to cross the bridge is 20 seconds. And in both the cases, the speed would be same. Am I correct? Why? Because in both the cases, the train speed would be same, because like we have to make sure, we need to make sure that length are different. Speed will be constant because the train is same. And then in the second case, length of the bridge is not required. Only the length of the train is required, which is again I think it is not given. Find the length of the train here. That is what we need to find out, and speed also we need to find out, right? And then what was the time that is required for himself? Himself means what? Time taken by the train to cross the man. So this is nothing but just like this. I can write which is 8 seconds. Right. If we make the equation from the first case, what would be? First of all, we have to make sure that we know this basic formula, that is distance is speed into time. Distance is speed into time, and our distance is nothing but simply the length, which is length of the train, which we do not know, which we have to find out, and then the length of the bridge, which is 180, right? And then what would the speed here? speed would be simply speed of the train, and then time taken by the train to cross the bridge, which is 20 seconds. So this is nothing but our first equation. And then from the second scenario, here we just have to consider the length of the train is equals to speed of the train into time is 8 seconds. Right? Here as we can see, so this is the common point here. If we just simply divide these equations, we will just simply can cancel this out, right? So LT plus LT plus 180 by LT, which is length of the train, is equals to 20 upon 8. Now why in the fractions, whenever in the fraction case, we just have to make sure we are not dealing with units here, because definitely the units will get cancelled. Like for example, in this case 20 seconds and 8 seconds is there, simply second would get cancelled. So in this scenario we can just ignore that fact. Now if you just simply cross multiply this, you can do 4 5s and 4 2s, so 2t 2lt plus 360 is equals to 5lt. So this is nothing but 360 is equals to 3lt, which is 120. So 120 meter, because 360 by 3 is 120, so 120 meter is nothing but the length of our train. Length of the train is 120 meters. Now we can simply put this in one of the equation and get our speed. So we'll just put in the second equation. So 120 is equals to st into 8. Now in this equation we have to make sure that your units are in this same manner, because here we are solving the equation, we are getting the value of st, right? And here we will just these values will get cancelled, these units will get cancelled, right? Now 120 is our meters and it is in seconds, so we will get our speed in meters per second. I think that's what we need. Or simply you can just actually speed of the train, you will always try to get it in kilometers per hour, because speed is always in kilometers per hour, train speed is always in kilometers per hour. So it is 120 meters, that is by 1000 kilometer. Now this is our kilometer is equals to st, and 8 seconds, right? 8 seconds by 60 minutes into 60, it would be hour. Now when we solve this particular equation, I hope you understood what I have written here. 8 by 60 into 60. Why? Because okay, just solve this. If we just solve this, 12 is equals to 8 into st upon 6. So 2 4s are and 2 3s are, and then again 4. So here 9, and then here again 1 6 is left here, right? So 9 into 6, that is 54 kilometer per hours. 54 kilometer per hours is our speed of the train. Just try to solve this equation and convert this meters in seconds into kilometers and hours. So for that, 120 upon 1000, we will be converting this into kilometers, and then 8 by 60 into 60, that is hours. So by solving that, we will get 54 kilometer per hour, which is the speed of our train. So in all the previous questions, the object that was that was like crossing the train, it was still, but in this specific scenario the object is moving, and when we see the object is moving, the concept of relative speed is used. Why? Because like when objects are moving in the for example in the same direction or in the opposite direction, the concept of relative speed would be used. In the previous cases, what was happening, for example, if you consider the man's case, man was standing still, right? Man was standing still, therefore we will just simply considering the speed of the train. When relative speeds come to the picture, that is when both of the objects are moving, we have to make sure that we are considering both of the objects' speed. Here the train of 150 km long is running with a speed of 68 km. So speed of the train is 68 km per hour, and we have to find out the time it will take to pass a man who is running at the speed of 8 km per hour. So now here speed of the man is also mentioned, which is 8 km per hour, And this is important. In the same direction is important. Why? Because if it is in the opposite direction, their speeds will get added. We have to make opposite direction. The speeds of man and the speed of the train will get added. But in this scenario, as they are moving in the same direction, their speeds will get subtracted. So whoever is bigger, it would be come here. It would come here. So definitely, most of the cases, in all of the cases, our train speed would be higher than the man speed. Right? So in the same direction means we have to remember the fact when it in the same direction, their speed it would get subtracted, and in the opposite direction their speeds would get added. Right? Now here, as speed of the train is 68, the speed of the man is 8, so our relative speed would be 60 km/h. And why do we need this? To find out the time which is taken by them to cross each other. It would be time. And here this speed is nothing but a relative speed, and this distance is nothing but the distance. We just have to add the distance of the object that is getting passed, or for example, when we see this kind of relative speed questions, either the two trains will be crossing each other or in the same direction, or the man would be crossing each other or in the same direction. Like that conditions will be there, right? So in the distance, in the case of man, we just have to write the distance of length of the train, and which is equals to speed of that is relative speed into time. So what is the length of this train? It is mentioned as 150 meters. So 150 meters is equals to relative speed, which is 60 km/h into time, and time would be in meters per second. So convert this 60 kilometer, that is 1000 upon 60 into 60. So this is directly cancelled. 4 2 3s are and 2 50s are. So 50 by 3, and this is 150. So this is okay. So this is nothing but time is 9 seconds. So time taken by a man by the train to pass a man who is moving at 8 km/h in the same direction is nothing but 9 seconds. So this is our fifth question. Here, a train of 222 meters is running with the speed of 15 km/h, and it will be, what will the time is required for train pass one who is running at 7 km/h in direction opposite. The only difference between this question and the previous question is that there the direction was same, and here the direction is opposite. And as I rightly mentioned, that in the case of opposite, we will consider our speeds to get added. So this would be our relative speed, and in the direction, if the direction is same, if they are moving in the same direction, their speeds will get subtracted. Right? Now, as this is our relative speed, distance is nothing but relative speed into time. So our distance is length of the train, which is 220 meters, which is equals to st plus sm, which is 59, which is the speed of the train, and speed of the man is 7 km/h. So this is nothing but km/h into time. So 220 meters is equals to 59 plus 7, 9 plus 7, which is 6, 66 km/h into time. So 220 into is equals to 66. So 220 is equals to 66 into 1000 upon 60 into 60. Right? And then simply 6 11s are, right? So this is 11 2s are. So 20 is equals to 10 upon 6. It's into t. Right? So simply t is equals to t is nothing but 12 seconds. So 12 seconds is the time which is required for the train to pass a man who is running at 7 km/h in the direction opposite to it. Now, so this is an important question. When we talk about two trains crossing each other or passing each other, this is one of the most important type of the question. So our first train, which is 137, first train length is 137 meters, and second train length is 169 meters. 169 meters. Right? They are running towards each other. Right? Towards each other means what? Direction is opposite. So speeds will get added. So their speeds will get added. So this would be our relative speed. Right. So what would be our relative speed? 42 and 48 are their respective speeds. 42 plus 48, which is nothing but 90. So 90 kilometer per hour? 90 kilometer per hour is our relative speed. Now when we talk about two trains, we have to consider the distance of both of the trains, which is 137 plus 169, which is nothing but 300. So it's not 116, it's 163 actually. So this is 163, which is 300. 300 meters is our added distance, added length. And when we talk about the formula, so distance, that is equals to speed into time. So here the length of the both trains, that is 300, would be equals to relative speed 90 into time that is required for it. So this is our solution. So now but the 300 is in meters and 90 is in kilometer per hour, which is 90,000 by 60 here into 60, nothing but 3 3s are 3 2s are 2 15s are 15 2s are, right? So it's nothing but, so if we solve this equation, we will simply get t is equals to 25, sorry not 25, it's 12. So t is equals to 12 seconds. So this is the time which is required for both of the trains to cross each other. So this is our 7th question. Here we have two trains, 100 meters and 120 meters long. They are running in the same direction. Now when we say same direction, in this particular scenario, our speeds will get subtracted. So what would be our relative speed? It would be the difference between 72 minus 54. As speed of the both of the trains is nothing but 72 and 54, which is 18 kilometer per hour. So this is our relative speed. Now in how much time will the first train cross the second? So simply we just have to find out the time which is required for them to cross each other, right? So that is the length is given as 100 plus 120, which is nothing but 220, which is equals to this is 18 into 1000 by 16 to 60y, which is simply converting this kilometer per hour into meters per second, as we need to find out time here. When we say time, we mostly go for seconds, right? Because it would require seconds for them to cross each other. So it is nothing but 3s and then again 22 into 6 upon 3 is equals to t, which is nothing but 3 2s and this is 44. So 44, that is 44 seconds. The time required is 44 seconds for both of the trains to cross each other when they are going in the same direction. Now, so this is our 8th question here. A train that is 100 meters, length of the train is 100 meters. It is taking 6 seconds to cross a man walking at 5 km per hour. Now this is the speed of the man. So speed of the man is given as 5 km per hour, and time taken by it, but by time taken by a train to cross that man who is walking at this distance, this speed is given as 6 seconds. From this we can draw out one equation that length of the train, that is 100 meters, is equals to speed of the train, right? Speed of the train is not mentioned here. We have speed of the man. Now speed of the train and speed of the man both are given, and also the scenario is given that they were in the opposite direction of the train. So man was walking in the direction opposite of the train. Now whenever there is the opposite direction, we have to make sure that we will add the speeds, right? So speed of the train plus speed of the man. So speed of 100 meters is st plus sm into time required for them to meet, which is nothing but 6 seconds, right? So this is 100 meters. It is in we haven't it yet find out, right? We haven't I mean this man speed is given, that is 5 plus st. It is nothing, it is in kilometer per hour. We cannot forget that. So this would be our first equation. So we can draw this equation out from the first scenario. Now from the second scenario, which is actually not given, we can just simply find out our speed of the train from this equation. Why? Because this is the only one variable that we have as unknown, right? So if we solve this 100 meters, right, and 5 plus st into 1000 meters by 60 into 60 into 6. So if it is easier for you to just try to understand what I have written here. Why I have written this? Because kilometer per hour, its units are kilometer per hour. This is meters, and this 6 is nothing but in seconds, right? Because of the time that is taken to meet each other, and this is in kilometer per hour. Now when we multiply, this whole thing is kilometer per hour. So in numerator we will have 1000, and then again in denominator we will have 60 into 60 for 60 minutes, and then again 60 for seconds. Now if we try to cancel this out, right, this both, so here we have 160, so it will go here. 60 is equals to 5 plus st, 5 plus st, therefore st is nothing but 55 kilometer. I hope you understood this. So as why? Because as this whole thing was in kilometer per hour, our speed is in kilometer per hour. So that is our train speed, which is 55 kilometer per hour. So this is our 9th question. Here we have two scenarios. So our first scenario is that train running at 54 kilometer per hour take 20 seconds to pass a platform. So this is our first. And then next it takes 12 seconds to pass a man walking at 6 kilometer per hour in same direction in which the train is going. Right. So from the first scenario, train running at 54 kilometer per hour. So speed of the train is 54 kilometer per hour. It takes 20 seconds to pass a platform. And when we say passing a platform, it has length of the platform. We have to make sure that we consider the length of the platform. So length of the train plus length of the platform would be equals to, as everything is stationary here, simply speed of the train into 20. Am I right? So this is our first equation. Now if we go to the second scenario, where it was taking 12 seconds for the train to pass a man, right? Passing a man, and man is walking at 6 kilometer per hour. So we have speed of the man, which is 6 kilometer per hour. Man is not still. It is the concept for the relative speed here, which is 6 kilometer per hour. Speed of the man is given. Speed of the train is not yet. Speed of the train is 54 kilometer per hour. And what would be the relative speed? When they are in here, the direction is same. So man and the train direction is same. Therefore there will be the subtraction of the speeds. So which is 54 minus 6, which is nothing but 48 kilometer per hour. So this is our relative speed. And what we can draw from here, as man doesn't have any kind of length, simply length of the train, which is equals to relative speed, which is 48, into time which is taken for them to meet each other, which is also not given, right? Which is not given. So sorry, it takes 12 seconds for the train to pass a man. So it is nothing but 12 seconds. And just make sure you know that it is this particular 48, it is in kilometer per hour. So length of the train is 48 kilometer per hour, which is 48 into 1000 meter by 60 into 60 into, now this is in 12. So 12 5s are simply, right? And then 6 8s are 5 20s are 20 into 6, that is 160. Am I right? So the length of the train is nothing but 160 meters. If you substitute the length of the train in this equation, we will get the length of the platform, right? length of the train, which is 160, plus length of the platform is equals to ST, which is 54, is into 20. 54 into 1000 by 60 into 60 into 20. So if we solve this, if we solve this equation, we will get our length of the platform, which is nothing but 140 meters. So 160 plus LP, this is 300 if we solve this, and then LP would be 140. Length of the platform is 140, length of the train is 160. So this is our 10th question and the last question for the day. Now here, a man is sitting in a train while which is traveling at 50 km per hour, and observes that a goods train observes goods train, and then the traveling in the opposite direction. So goods train is traveling in the opposite direction to the train in which a man is sitting, and it takes 9 seconds to pass him. If the goods train is 280 meters long, find its speeds. So first of all, we have to understand here, when we say man sitting in the train, here we cannot directly talk about the train distance. Why? Because here the observation is done by man itself. Here we are not saying like two trains have crossed each other and we are find the time that is required for them to cross each other. No. Here simply a man is sitting inside the train, and from his perspective he is watching the train which is coming opposite from his direction. And then so here simply the scenario is man and the train, right? So speed of the man here we have to consider as speed of the train itself, which is nothing but 50 km per hour. And then speed of the goods train is something that we need to find out. And length of the train, length of the man's train, it's completely negligible, because here the train of the length of the train of the in which a man is sitting is not at all in the picture. Only the man is in the picture, right? So it is as it is in the opposite direction, speeds will get added. So it is nothing but 50. So relative speed would be 50 plus SG, kilometer per hour. Am I correct? I hope it is understood, because here as 50 is nothing but the speed of the train in which man was sitting, we have to consider man's speed as 50, and then again we have to write here as SG plus SG as they are moving in the opposite direction. So this is nothing but our relative speed, and distance is nothing but only 280. Why? As I've mentioned, only we have to consider the goods train length, not the man's length. So as man is considered here, we have to completely ignore the length of the man. So 280 is equals to relative speed, which is 50 plus SG into time taken, which is 9 seconds. So 280 upon 9, which is equals to 50 plus SG. So this is meters per second, right? So simply, and then again we have to make it kilometers per hour, right? As we have to find the SG here. First of all, just whole term, if we find out here, it is nothing but 280 upon 9. Now, as this is in meters per second, 280 into 1000. 280 upon 1000, that is kilometer, and as it was by 9 initially, upon it will go for 60 into 60, which is 50 plus SG. Why this? Because we are converting this 280 upon 9 meters per second into kilometers per hour. So the 280 meters was there, so by 1000 means kilometer, by 9 was there, so and simply 1000 by 60 into 60. So as it was in the denominator of this 1000, it will go in the numerator, right? So that is with 280 into 60 into 60. If we solve this complete, just simply solve this. 9 3 2s are 3 3s are, right, 3 2s are, so this is nothing but 28 into 3, right? 20 into 3. Why? Because here if I just simplify it here, 280 upon 1000 into 60 into 60 upon 9, right? So if this is zeros will get cancelled out, and 6 3 2s are 3 3s are, right? And then again 3 2s are, so 28 into 4, 28 into 4 actually, which is nothing but 112. Not 28 into 3, it is 28 into 4. So 28 into 4 km per hour is our relative speed. It is 50 plus sg. 50 plus sg is 112. So sg, that is the good strength speed, would be 62 km per hour. I hope you understand why we have considered here the speed of the man, not the train, because man is sitting inside the train and we are seeing here from the man's perspective. So this is our last question, and I hope you understood the video. Follow for more.